I wanted to very quickly go through some more of the examples of log examples, but I also wanted to do this using a different type of scientific calculator. The type of calculator that I used in the previous videos was very similar to this type of calculator, TI-30X2S. It had a very similar syntax, and it also had a very similar syntax as TI-83 series, which is why I like the TI-30X2S and why I think it's very easy to use. But at the same time, not everybody has these types of scientific calculators. Also, the TI-30XS is pretty similar for the most part. It's TI-30XS is kind of a newer version of the TI-30X2S. But if you have, on the other hand, if you have a TI-30XA, the XA has a very different type of command syntax, so you use it very differently. But most scientific, this has the same syntax that most scientific calculators do, which is why I wanted to go ahead and go through this again using this type of syntax. Now, not every scientific calculator is the same. In fact, no two are alike for that matter. What I'm going to do here is probably going to be pretty similar to the TI-30XA, but it will not be the same. So you want to go ahead and try it out. Use different examples and see if you get the correct answer. Play around with it until you realize what's working. The hardest part of this section of Chapter 12 is using the calculator, but if you know how to use a calculator, it's a breeze. So, one thing I do want to mention, and this is not something that's going to be, this is something that applies to all TI calculators, and probably a lot of Casio and HP as well. Now, I don't have any experience with Casio or HP calculators, so there's not much I can do to help you with those. But whenever you have a button like on the TI-30XA, there's the LN key, and it looks something like this. So you have the LN button, and right above it, there's the E to the X button. Whenever you have a button that says one thing, and then something above it as well, that's not actually on the key, then to reach this function, you first have to hit second, and then the LN key. So let's say I wanted to take e to the power of e to the power of 4 or something, I don't know. So if I want to do e to the power of 4 in order, first I'd push 4, then I would push the second key, then I'd push the LN key, because LN key, the second function of the LN key is e to the x. Then I'd hit the enter key, and it'll display e to the power of 4. Now let's see what e to the power of 4 is. I don't even know. E to the power of 4 should be 554.5982. That's kind of a sloppy 8. So this is the button sequence I would push to get e to the power of 4 on the TI-30XA. Okay, so the reason why I'm pointing this out here is because, also on some calculators this might say shift instead of second. In fact, the scientific calculator that I'm going to be using uses shift instead of second. The reason I got this scientific calculator from calculator.org. It's an in-browser calculator. Now, but that being said, the reason why I'm using this is because it's similar to the TI-30XA, and because it's similar to some other scientific calculators. This uses shift, but it's a little bit different because if you have shift, then it actually changes if you use shift, it actually changes the sorry, I got a text message, so I got distracted. It changes what it says on the button, so it's a little bit different from when you actually use a physical calculator, because a physical calculator can't change what it says on the buttons. So let's go ahead and try this out. Let's try this example. So we have we have that this is an example from the problem set. We have that a equals c times e to the power of negative 0.0004279 times t. So this is our equation, and it's a word problem, but when you read the word problem, you'll find that c equals, I think it was 6, yeah, 6, and t equals 1000. So let's go ahead and plug this in. So what this means, obviously, is we're going to be plugging 6 in for c and 1000 in for t. So we will get 6. Oops, sorry. Why is this not? Okay. We get 6 times e to the power of negative 0.0004279 times 1000. I'm just plugging it in, so I'm just plugging in c and 1000. Let's go ahead and clear that off. So the way I want to solve this using a scientific calculator is kind of backwards. You know, for the TI-30X2S series, you just plug it straight in pretty much, and you've seen me do that in other videos. But let's go ahead and do this using this example. So first thing I want to do is I want to simplify this a term at a time. I want to do this one step at a time, and the first thing I want to do is multiply these two things together. Now we could do this by eyeing it pretty easily enough, but if you're in the middle of a test, then it's sometimes the obvious things become no longer obvious. I've been there, so let's clear this off. And we want to do negative all this stuff, so 0.0004279. Now, for this calculator, you first enter the number and then you switch it to a negative, and then times 1000, enter, and it gives me that. So this simplifies down to e to the power of negative 0.4279. Did something else here. Okay. This new version of this program will it will give me a glaring error if I type something in wrong. Okay, so all I did here was I simplified this part here. And I want to write down the new version, because otherwise you'll get confused. Now, to take e to the power of 0.4279, I want to find the e to the a key. So I want to take this. To do this on this type of scientific calculator, I first push. Oh, and on TI-30XA, this will say e to the x, not e to the a. And now I first type in the 0.4279, and then type in the e to the a, and it gives me this number here. So let's start that from scratch, just so that we understand it. So if I want to take e to the power of negative 4279, I'll do 0.4279 negative, and then e to the power of a. So e to the power of a is 0.65 blah blah blah. So it's in reverse order. Whereas on most calculators you do e to the power of this. Here you type in this and then you hit e to the power of. So let's go ahead and now we've simplified this term. Now we have an approximation. We can't you could write down all these numbers if you wanted to, but I only expect about 4 decimal places of precision. So we have 6 times about 0.6519. That's just rounding to 6 places of precision. So I've simplified this term to this. So now I just take this and I multiply it by 6. So I can take the previous answer and multiply by 6 to get 3.91. Um, 1.3. So this is going to be our final answer. It's going to be 3.9113. So it's really not hard to do it as long as you understand what you're doing. Also, this is a case where it's very good practice to write down your individual steps. For the TI-30X2S, you could type all this in here at once. But some people, even with the TI-30X2S, they'll want to go ahead and write down the individual steps, because that way it's easier to keep track of everything. So let's go on to another example, one that uses logarithms. By the way, when you go into trig, you will see you'll be using this sine, cosine, and tangent functions, and it'll have the same format that the log and natural log does. I mean, you'll be using it the same way. You'll first type in the number that you want to take the sine of, then you'll take sine, and it'll do it. That's quite a ways away, but I thought I'd mention that since I'm just thinking of it. I think we can skip anything from 12.2 because it doesn't really use the calculator. But 12.4, let's say we want to take the log of log of 12.3. Okay, so to take this is the common log of 12.3. So to do that, first I'll clear this off, and then I'll type in 12.3, and then I'll hit the common log button, and it'll give me about 1.0899, and that is the same answer that I got using the TI-30X2S. And as another example, if I wanted to do just a quick example, do log of 8. So I'd clear this off, do 8, then type in the log key, and it gave me 0.903. So 0.9031. I rounded this last term up to 1. Now, different calculators have different levels of precision. There's a chance that your calculator might say 0.9032. And that happens sometimes. You need to be pretty close. You know, if the answer that you have is just a little bit off from the answer in the back of the book, then that's fine. But if this said 7 or 8, like these two terms pretty much can't be off. This one might be off by 1. This one might be off by 1 or 2. That happens just because different calculators have different levels of precision. But try to, you know, if your answer is way off, that means you didn't do it right. So either that or there's something wrong with your calculator, in which case you obviously need to get a new one. But just be aware that if your calculator gives a slightly different answer, then you're probably fine. Now let's do an example that involves common logs. So we have natural log of 1.53. So to do this, first I clear this off. 1.53 natural log, and I get 0.4253, about, round that last term off. So that means this is about 0.4253. And one more example using natural logs would be 0.00579. The exact same way. Type in 0.00579 natural log, and I'll get negative 5.1516. And that's the same thing I got using the other calculator. It's exactly the same thing, actually. So let's also do one more example using this type of problem. Now, let's say this is not a strictly calculator problem, but it's still something that uses the calculator to solve. Let's say we have solve log of x equals 6.4683. Well, to do this, we need to figure out we need to put this equation in terms of x. So remember that the definition of common log is that we can rearrange this equation to be 10 power of 0.64683 equals x. Because this just means, if we want to use the counterclockwise principle or method, whichever way you want to think about it, common log just means log base 10. And so log base 10 of x equals 6.4683. So we want to use the counterclockwise principle. Start with the same base, go to this exponent, go to this x, which is what I have here. So to solve this, first I'd clear this off. Now you could use this, but not this button. What was what I was looking for? You could use this right here, but I kind of like to do an example that involves just a regular, what's the word I'm looking for? Just a regular exponent. So let's say this x to the a button right here. We want to do 10 raised to the power of 6.4683 equals a huge number, and that's to be expected. You're supposed to get a huge number for this problem. 29396979.6095. This is the same thing that I got with my other calculator. Because think about this: 10 to the power of 6 is going to be a million. So that means 10 to the power of 6.4 blah 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 is going to be even bigger than a million. So sorry, I forgot where I was going with that. I'll pick it up eventually. Oh yeah, so this x to the a button, basically you enter the first term, enter the base, hit the x to the a, then enter the exponent to take the exponent of any two numbers. So if I wanted to take 3 to the power of 4, let's clear this off. So I'd say 3 to the power of 4 equals 81. Well, that makes sense because that's going to be 9 times 9, which is 81. So that's just something to keep in mind. This is slightly different syntax from the other buttons. Now, most calculators, and this one does too, has a 10 to the a. So if I wanted to do this starting over using that, I could do 6.4683 e to the a, and I get the same thing. But the reason, I just wanted to go ahead and show you the x to the a feature. Either one will work. If you're more comfortable with the x to the a, that'll work. But try to avoid using the x to the a for the e. I mean, e is technically about 2.71828. Yeah, that sounds right. 2.71828. But you don't want to approximate it that much. You want to go ahead and use the e to the a button, because otherwise you'll just be way too far off. Okay, let's go ahead and clear that off. So, oh, well, I didn't actually write the answer. What the heck, I might as well go ahead and try it again. So I have 10 to the power of 6.4683 equals x equals 2,939,679.6095. So this is our new number. Not our new number, our x. Okay, let's clear that off. And I'm not going to do another example like that. I do want to do one change of base example, though. I'm going to use natural log. If for whatever reason you want to use common log, it'll work just as fine. It might have a slightly different answer. Remember, like how I said, different calculators might have 1 or 2 off on the last digit. It's the same thing if you use common log instead of natural log, but it'll still work. I would still take it as an answer. Some teachers say you have to use a specific one, but it doesn't really matter. So log base 3. I did something. Okay, log base 3 of 9.42. Sorry, I miscopied it. So let's do log base 3 of 9.2. Okay, well, if this was 9, then that'd be easy. It'd just be 2. But log base 3 of 9.2, well, that's kind of funky. So first thing I need to do before I even touch the calculator is I need to rewrite this. I need to rewrite this as a fraction of natural log of 9.2 over natural log of 3. So I just rewrote this as natural log. This is using the change of base formula. If you don't understand it, then go back to the 12.4 video. It should be up. If it's not, then I'll correct that. And then go ahead and for the calculators that I used before, that's similar to the TI-30X2S, you would just type this in directly. At least you could. You don't necessarily have to. Actually, even using that, you could still use the same method I'm doing here. But now let's go ahead and do this individually. Now, you could probably use these parentheses, but since you don't have an inline display, it can be kind of confusing, so I prefer not to. Parentheses, I think, are better for inline display purposes. So first, let's take the natural log of 9.2. So 9.2 natural log is about that. So it'll be about 2.21920. How far did I go? Okay, I went one digit more than I should have. So it's about that. So then we want to do natural log of 3. So clear it off. So we'll do 3 natural log is about 1.0986. Okay, so now I've approximated the natural log of 9.2 and natural log of 3. Again, you could probably use these parentheses, but it would be, since you don't have an inline display, I personally think that's a little bit harder to use. And it's like that for most other scientific calculators. You'll see these parentheses on there, but if you don't have a string, an input string to see, I think it's kind of hard to use it that way. That's why I like to do it a step at a time like this, in this case. So, we want to go ahead and do this fraction, so we'll do 2.2192. You could probably store this using the store command, but that I don't want to. this m plus. So 2.2192 divided by 1.0986 is equal to about 2. So I'm approximating again. About equal to 2.0200. You don't need to put the 00 on there if you don't want to, but this is the same answer that I got using the calculator directly. 2.0200. So that's one example. Let's go ahead and do one more example. Base 7 of 7.35 is approximately, not approximately, it's exactly. It's going to be exactly log of 7.35 over log of 7. Okay, I'm just using the change of base formula, log of 7.35 over log of 7. I just realized that I accidentally used common log instead of natural log, but that's fine. Natural log is generally preferable, but you should get the same answer. And since I have it written down here, I'll go ahead and use the common log here too. So, I'll do the log of 7.35. That turns out to be that. Let's go ahead and write that out. So now it's approximately 0.86623. If we want to round it, it'll be 3. Why is there an equal sign too? Let's get rid of that equal sign. Okay, so that's the approximation of log of 7.53. And now let's do log of 7. So clear all 7 log. And if you do use natural log if you do use common log on top, it has to be common log on bottom. Keep that in mind. You can't mix and match these. It has to be either common on both or natural on both. So that is going to be 0.8451. So now I want to go ahead and put this into the calculator. Clear all, we'll get 0.8663 over 0.8451, which comes out to about 0.0251. So that's about 1.0251, and that's the same answer I got using the other calculator. Now, that's all the examples that I have from the review for the quiz. Let's go ahead and I'm going to make one up using the common log. Using change of base formula again. So let's say we have log base 5 of 7. Okay, well, using the change of base formula, this will be equal to log. Fraction. The fraction of log base 7 over log base 5. And if it's all the same to you, I'm going to change that to natural log instead of common log. So natural log of 7 over natural log of 5. And we're going to approximate that with the calculator. The natural log of 7, clear that off, say 7 natural log 1.94 blah blah blah. So that's going to be equal to 1.9459. Yeah, that's 4 decimal places. So that is the... Oh, I put an equal sign again. I didn't mean to do that. And now we want to approximate natural log of 5. So clear all 5 natural log. And that's 1.6094, and that's as far as the approximation goes. And now let's go ahead and approximate this fraction. So bear in mind that these are approximations, not exact numbers. It's as far as the answer is concerned on like a quiz or a test, that doesn't really matter, but it's still pretty important to understand. To understand what you're doing, you should probably understand this is an approximation, not an exact number. So let's go ahead and do this. 1.9459 over 1.6094 equals 1.2 blah blah blah. 1.2090. Oh, that's I typed that in wrong. 2090. There we go. And that makes sense because 7 is not a whole lot bigger than 5, so 1.2090 will get you 5 to the power of not much more than 1 will get you 7. Alright, that's all I got for this. So hopefully that's helpful if you're having a hard time using your calculator. But again, the best way to do that is just to play with your calculator yourself. Now I will say there's a reason why I use the TI-30X2S. I think it's the easiest one to use. And the examples that I did before using the scientific calculator program that I was using before has a similar syntax as that. Not exactly the same, but pretty close to it. So at any rate, hopefully that will be helpful, and good luck on the quiz.